Hello, my name is Patrick Nieborg, and in this video I'm going to show you a brief overview of the new features of Thea 1.5. Let's start with feature number 1. Under Custom Preferences, we have a new entry, a new tab, Extra tab, and here we can see all our supported render passes. And this means that we can now save all the render passes in one multi-layered Excel. So with Thea 1.5, we support multi-layered access. You can select the bit depth for each render pass, and we have also a force save as RGB component because unfortunately Photoshop, for example, can only read RGB XR images. For example, other compositing programs like Nuke or Fusion, they can read grayscale images, for example, for the depth pass. So in this case, depth pass can be just one image, and we don't have to save three channels RGB. So with one channel is enough. So in case you want to use it with Photoshop or similar programs, or your compositing program doesn't support grayscale images and also needs RGB components, enable this one. If you don't want to save as a multi-layered EXA, just disable it, and then each render pass will get saved as a single image, a single EXA image. And finally, show this dialog when saving. Well, if you don't want to see this each time you're going to save as EXA, you can disable this one. You can also do this the next time it pops up. So that's it with the multi-layer EXA support. Feature number 2. This is a real photo of a Lamborghini, and you probably recognize this car paint. It's a typical Lamborghini orange, yellow orange, and yeah, recreating this car paint is not that easy. And if we look at it, well, we have like different shades of orange. We have here even some kind of yellow, and then it fades to an orange, and then we have here more saturated orange, a deeper saturated orange. So let's try to recreate this inside Thea. So here I have my test car, and well, I have my basic color with diffuse, nice orange, and also to simulate a little bit this pearl, which is something similar like metal flakes, just they're a little bit like transparent. So I give the reflectance also a color, and yeah, on top I give it a quoting. Let's see how this looks like. Well, we get some yellow here, but the rest of the car, well, there is no big difference. It's like a pale orange, and I really tried hard. Here with the orange, I tried to go a little bit more saturated, but the overall look has nothing to do with the image we just saw with the real photo. And also with the saturation, I try to go as high as I can, and there seems to be no way to get this kind of colors until now. Because the fact we're seeing here is because the color used in the real car is semi-opaque, meaning that the base color underneath this orange color can show through. And if you have seen how cars are painted, you probably know that first there is like a white base color, everything is nice, polished and white, and then you spray over the final color. So we have implemented something similar. So I have here the material ready, and I will drop it on, and just let's see how it looks like. And wow, there's a huge difference. You see, we get now this gradient. There are orange, more intense orange over here also. So now if we compare, it looks much closer to the real thing. So let's see how this is built. First we have our base, like it would be in reality, which is basically white. A white color, and we have our reflectance and the roughness of 30. So this would be like our base color to prepare the car. And then on top we have now our coating with absorption. So this will mimic exactly like this semi-opaque color. Now to enable this we have to enable the thickness, because the thicker the coating is, the more intense the color will be, and the more it will affect the underlying this color over here. So we can make a test. Let's just lower the thickness, just half. You see, now it's more a yellow car, but it still has these tones that goes to a deeper, nearly orange-like yellow. And again, if you know this Lamborghini colors, there are colors like that. So how does it work? It works exactly the same like absorption with glossy glass. You know, when you add absorption to glass, that the light get absorbed, and some wavelengths get absorbed and others reflect back, and that will be the final color of the glass. So, but in glass, the thinner parts will be lighter than the thicker parts, because the light has to travel through the thicker parts much longer, and so much more wavelengths get absorbed. So the color is more intense. Now, something similar happens with this coating, just as a very small, we are talking about microns here, but the physics are the same. So the light hits here, and underneath the white can shine through. So the color of the varnish is brighter, it's lighter. And where the light doesn't hit so much, well, it gets more absorbed, and we get this variations of tones. We can increase, let's say we go to 150, and look, we're getting a hue shift, and now it's nearly red. So by controlling the thickness, we can control the color and also how much is seen from the base. So let's set this back to 100. We'll have our nice orange color. We can also alter the absorption color, and it works similar. So if I lower the saturation, it's like similar like lowering the thickness. You see now we're getting more to a yellow tone. The more I lower it, the more yellow it becomes. Let's set it to 0. You see the white base. And so we can also change it to another color. You see the color now on the car is much richer and much deeper, something we could not do before. And yeah, I have another car paint, this one here. You see, this time what I did is I give the diffuse color, base color, one color, and the quoting color a different one. And so now the colors are fading from one to another, giving this nice effect. So maybe this could be replicated with some ramp shaders, but keep in mind that here we are talking about transparency, and it also has to do with where the light hits. For example, let's select the light. We have our sun here. And if we change now the direction, you see the colors also change because now less light is coming from one side. So the color will be darker. I change it around. So it's not only view dependent, it's also light dependent. So it's quite complex. And you see it's very, very easy to reproduce now this kind of paints. Now there's another paint or another situation where this would be very handy. For example, wood furnitures. They're also based on colored or tinted varnish because furnitures, they get their color from tints. They don't grow with this kind of colors. So if you ever have seen how a furniture is created or restored, you know that also we have a tint, and then at the final we add a coating, a varnish on top, and this varnish also has a tint. It's a light tint, depends. There are some more saturated, others very light saturated, and this will also give an effect that gives this wood furniture this depth, and yeah, you immediately see that this is wood and not plastic. So it will help you a lot also in your wood rendering for floors, for furnitures, whatever. So that was feature number 2. Feature number 3 is the improved shadow catcher. So again, we have our car and we have an infinite plane where I have added a shadow catcher. And I also have added a reflectance. So to have a little bit of reflection on the ground. Now, to use this, only use reflectance. Don't use diffuse. So in this case, it's better to use the glossy. And well, for the environment, I'm using an HDR for illumination and a backplate shoot at the same location where the HDR was shoot for the background. So let's see how this looks like. So immediately we can see that there is no ambient occlusion anymore. Now these are real shadows and they are actually produced by the HDR. So selecting now the shadow catcher plane, I have given it a little bit of reflection. So I will tone this down so you can see a little bit better. So now, of course, these are now crisp reflections that doesn't fit very well with the environment. So I give that again, let's say 20. Okay, that's good enough. And that's all about feature number 3. Feature number 4. Feature number 4 is our Fresnel ramp. It's an artistic friendly version of our Fresnel curve, and it's often used, it can be used for recreating cloth materials or velvet materials or any kind of materials that have a difference between the reflectance 0 and 90 as it describes the viewing angle. So let's have a look how this works. We go to the procedurals and here we have the Fresnel ramp. Clicking on the option icon, we see the option panel and the curve window. So by default we have the Fresnel reflection or reflectance, where we have the index of refraction and the exponent value. Down here we can see the curve produced by these values, and here we see reflectance 0 on to reflectance 90. So right now we can see that There is the dark value is on reflectance 0 and the bright value is on reflectance 90. So we start rendering, and that will be the result by default. Now, to alter the curve, we can increase the index of refraction, which basically makes the curve more flat. So the higher we go, the flatter the curve will be, and nearly no gradient is created. If we go the opposite way and lower the index of refraction, we get a much more pronounced curve, something like 1.1. You can see that now the curve is very pronounced. We get the high color on the edges, and the low color is the dominant one. So instead of using black and white, we can also change the color to something else, the high color, and now we have a red cloth material. So let's set this back to 1.5, and the exponent works similar to the index of refraction. So if we lower this one, we're making the curve flatter, and if we increase this one, we make it more pronounced. You can also see it here on this preview. So we've got quite some control over the curve this way. Now the next ramp type is the Fresnel transmittance, which is exactly the opposite of the Fresnel reflectance. So you can also see it here. It's the opposite gradient. You can experiment with it. The next one is linear increase. And in this case, the index of refraction is disabled. We only have the exponent value. And you can see here the kind of gradient it produces. So by increasing the value, we can recreate a very nice curve that resembles velvet-like material quite nicely. So this is one of the curves I would recommend if you want to recreate this kind of material. Let's reset this to default settings. The next one is linear decrease, which is the opposite of the linear increase. So instead of going from dark to bright, it goes from bright to dark. And again, you can change here the values, make it more pronounced, or go the opposite, and basically create a flat shader. Now we have the gray curve. In this case, there's no index of refraction and no exponent. They're grayed out, but what we can do now is draw directly inside the window. So the best thing is to start with a low resolution. We have here different type of resolutions. So starting with a low resolution, then building the curve. I like to create a S-shaped curve, which gives very nice results for velvet materials. And finally, we have then also the RGB curve. Now the RGB curve, also the low and high color are disabled. Now we can control the red curve, the green and the blue curve separately. Right now, with this box around the red dot, means that the red curve is selected. So I can create the red. Now I change to the green one. And finally, I change the blue one. Now, the RGB curve is probably not the best curve to use when we are wanting to recreate cloth materials, but it will come in handy for other type of materials I will show you later. There is something else. Let's go back to our gray curve. Let's quickly recreate this one. Yep. Something like that. So what if we want to use an image bitmap instead of a plain color? We can do this by first resetting the high color to white. And now what we have to do is in the second slot next to the Ferrari ramp, we load a texture. I have already prepared a material for that, so I will just drop it in. And here you can see we have our ramp and the texture. Now, the texture, you can increase the brightness or the saturation just through the tone mapping. And if you want to have more control over the low color, you can do this also. In this case, we will need to add the same texture here under the Fresnel ramp. For that, I have also a text material ready. You see, in this case, I wanted to have the low color very blue and saturated, and the high color brighter and not so saturated, because it gives this nice cloth effect. So again, we do this through the tone mapping for the textures, and all the rest is just the same. We alter the curve to get our gradient, and that's it. Now let's go back to the RGB curve and see what kind of materials we can recreate with that one. For that, I will load up the advanced material scene, and I also have some materials ready here. So the Fresnel curve can be used on the diffuse channel, the reflectance, and translucency. In this case, I'm using it on the reflectance. So this is the type of RGB curve I have recreated. We can see here the gradient, and I'm using it for the reflectance. I've also increased the index of the extinction coefficient to have more reflection, so it looks more like a pearl material. So we can have a look, see how this looks like. And you see, we get now this. I have given a roughness of 15. Can also bring this down to 0. So this type of material would be a candidate for our RGB curve. I have here another material. This one is with translucency. You see, I have used the reflectance, the Fresnel ramp in the reflectance and in the translucency. Here again, our RGB curve, and we can achieve quite some interesting effects this way. Well, this was the last of the new features, and I hope you enjoyed it. My name is Patrick Nieborg, and I hope I see you soon again. Bye bye.